A blockchain, originally blockchain, is a growing list of records, called blocks, that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data, generally represented as a Merkle tree. By design, a blockchain is resistant to modification of the data. It is an open, distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. For use as a distributed ledger, a blockchain is typically managed by a peer-to-peer network collectively adhering to a protocol for internode communication and validating new blocks. Once recorded, the data in any given block cannot be altered retroactively without alteration of all subsequent blocks, which requires consensus of the network majority. Although blockchain records are not unalterable, blockchains may be considered secure by design and exemplify a distributed computing system with high Byzantine fault tolerance. Decentralized consensus has therefore been claimed with a blockchain. Blockchain was invented by a person, or group of people, using the name Satoshi Nakamoto in 2008 to serve as the public transaction ledger of the cryptocurrency Bitcoin. The identity of Satoshi Nakamoto is unknown. The invention of the blockchain for Bitcoin made it the first digital currency to solve the double spending problem without the need of a trusted authority or central server. The Bitcoin design has inspired other applications, and blockchains that are readable by the public are widely used by cryptocurrencies. Blockchain is considered a type of payment rail. Private blockchains have been proposed for business use. Sources such as Computerworld called the marketing of such blockchains without a proper security model snake oil. History. The first work on a cryptographically secure chain of blocks was described in 1991 by Stuart Haber and W. Scott Stornetta. They wanted to implement a system where document timestamps could not be tampered fault with. In 1992, Bayer, Haber and Stornetta incorporated Merkle trees to the design, which improved its efficiency by allowing several document certificates to be collected into one block. The first blockchain was conceptualized by a person, or group of people, known as Satoshi Nakamoto in 2008. Nakamoto improved the design in an important way using a hashcash-like method to timestamp blocks without requiring them to be signed by a trusted party and to reduce speed with which blocks are added to the chain. The design was implemented the following year by Nakamoto as a core component of the cryptocurrency Bitcoin, where it serves as the public ledger for all transactions on the network. In August 2014, the Bitcoin blockchain file size, containing records of all transactions that have occurred on the network, reached 20 gigabytes. In January 2015, the size had grown to almost 30 gigabytes. And from January 2016 to January 2017, the Bitcoin blockchain grew from 50 gigabytes to 100 gigabytes in size. The words block and chain were used separately in Satoshi Nakamoto's original paper, but were eventually popularized as a single word, blockchain, by 2016. Smart contracts that run on a blockchain, for example, ones that create invoices that pay themselves when a shipment arrives, or share certificates that automatically send their owners dividends if profits reach a certain level, require an off-chain oracle to access any external data or events based on time or market conditions, that need to interact with the blockchain. According to Accenture, an application of the diffusion of innovations theory suggests that blockchains attained a 13.5% adoption rate within financial services in 2016, therefore reaching the early adopters phase. Industry trade groups joined to create the Global Blockchain Forum in 2016, an initiative of the Chamber of Digital Commerce. In May 2018, Gartner found that only 1% of CIOs indicated any kind of blockchain adoption within their organizations, and only 8% of CIOs were in the short-term planning or looking at active experimentation with blockchain. Structure. A blockchain is a decentralized, distributed, and oftentimes public, digital ledger that is used to record transactions across many computers so that any involved record cannot be altered retroactively, without the alteration of all subsequent blocks. This allows the participants to verify and audit transactions independently and relatively inexpensively. A blockchain database is managed autonomously using a peer-to-peer network and a distributed timestamping server. They are authenticated by mass collaboration powered by collective self-interests. Such a design facilitates robust workflow where participants' uncertainty regarding data security is marginal. The use of a blockchain removes the characteristic of infinite reproducibility from a digital asset. It confirms that each unit of value was transferred only once, solving the long-standing problem of double spending. A blockchain has been described as a value exchange protocol. A blockchain can maintain title rights because, when properly set up to detail the exchange agreement, it provides a record that compels offer and acceptance. Blocks. Blocks hold batches of valid transactions that are hashed and encoded into a Merkle tree. Each block includes the cryptographic hash of the prior block and the blockchain, linking the two. The linked blocks form a chain. This iterative process confirms the integrity of the previous block, all the way back to the original Genesis block. Sometimes separate blocks can be produced concurrently, creating a temporary fork. In addition to a secure hash-based history, any blockchain has a specified algorithm for scoring different versions of the history so that one with a higher score can be selected over others. Blocks not selected for inclusion in the chain are called orphan blocks. Peers supporting the database have different versions of the history from time to time. They keep only the highest scoring version of the database known to them. Whenever a peer receives a higher scoring version, usually the old version with a single new block added, they extend or overwrite their own database and retransmit the improvement to their peers. There is never an absolute guarantee that any particular entry will remain in the best version of the history forever. Blockchains are typically built to add the score of new blocks onto old blocks and are given incentives to extend with new blocks rather than overwrite old blocks. Therefore, the probability of an entry becoming superseded decreases exponentially as more blocks are built on top of it, eventually becoming very low. Ch. 08 For example, Bitcoin uses a proof of work system, where the chain with the most cumulative proof of work is considered the valid one by the network. There are a number of methods that can be used to demonstrate a sufficient level of computation. Within a blockchain, the computation is carried out redundantly rather than in the traditional segregated and parallel manner. Block time. The block time is the average time it takes for the network to generate one extra block in the blockchain. Some blockchains create a new block as frequently as every 5 seconds. By the time of block completion, the included data becomes verifiable. In cryptocurrency, this is practically when a transaction takes place, so a shorter block time means faster transactions. The block time for Ethereum is set to between 14 and 15 seconds, while for Bitcoin it is on average 10 minutes. Hard forks. Decentralization. By storing data across its peer-to-peer network, the blockchain eliminates a number of risks that come with data being held centrally. The decentralized blockchain may use ad hoc message passing and distributed networking. Peer-to-peer blockchain networks lack centralized points of vulnerability that computer crackers can exploit. Likewise, it has no central point of failure. Blockchain security methods include the use of public key cryptography. 5 A public key, a long, random-looking string of numbers, is an address on the blockchain. Value tokens sent across the network are recorded as belonging to that address. A private key is like a password that gives its owner access to their digital assets or the means to otherwise interact with the various capabilities that blockchains now support. Data stored on the blockchain is generally considered incorruptible. Every node in a decentralized system has a copy of the blockchain. Data quality is maintained by massive database replication and computational trust. No centralized official copy exists and no user is trusted more than any other. Transactions are broadcast to the network using software. Messages are delivered on a best effort basis. Mining nodes validate transactions, add them to the block they are building, and then broadcast the completed block to other nodes. Ch. 08 Blockchains use various timestamping schemes, such as proof of work, to serialize changes. Alternative consensus methods include proof of stake. Growth of a decentralized blockchain is accompanied by the risk of centralization because the computer resources required to process larger amounts of data become more expensive. Openness. Open blockchains are more user-friendly than some traditional ownership records, which, while open to the public, still require physical access to view. Because all early blockchains were permissionless, controversy has arisen over the blockchain definition. An issue in this ongoing debate is whether a private system with verifiers tasked and authorized, permissioned, by a central authority should be considered a blockchain. Proponents of permissioned or private chains argue that the term blockchain may be applied to any data structure that batches data into timestamped blocks. These blockchains serve as a distributed version of multi-version concurrency control, MVCC, in databases. Just as MVCC prevents two transactions from concurrently modifying a single object in a database, blockchains prevent two transactions from spending the same single output in a blockchain. Opponents say that permission systems resemble traditional corporate databases, not supporting decentralized data verification, and that such systems are not hardened against operator tampering and revision. Nikolai Hampton of Computer World said that many in-house blockchain solutions will be nothing more than cumbersome databases, and without a clear security model, proprietary blockchains should be eyed with suspicion. Permissionless. The great advantage to an open, permissionless, or public, blockchain network is that guarding against bad actors is not required and no access control is needed. This means that applications can be added to the network without the approval or trust of others, using the blockchain as a transport layer. Bitcoin and other cryptocurrencies currently secure their blockchain by requiring new entries to include a proof of work. To prolong the blockchain, Bitcoin uses hashcash puzzles. While hashcash was designed in 1997 by Adam Back, the original idea was first proposed by Cynthia Dahlberg and Money Nair and Dli Poniatowski in their 1992 paper Pricing via Processing or Combating Junk Mail. Financial companies have not prioritized decentralized blockchains. In 2016, venture capital investment for blockchain-related projects was weakening in the USA but increasing in China. Bitcoin and many other cryptocurrencies use open, public, blockchains. As of April 2018, Bitcoin has the highest market capitalization. Permissioned, private, blockchain. Permissioned blockchains use an access control layer to govern who has access to the network. In contrast to public blockchain networks, validators on private blockchain networks are vetted by the network owner. They do not rely on anonymous nodes to validate transactions nor do they benefit from the network effect. Permission blockchains can also go by the name of consortium blockchains. Disadvantages of private blockchain. Nikolai Hampton pointed out in Computer World that there is also no need for a 51% attack on a private blockchain, as the private blockchain, most likely, already controls 100% of all block creation resources. If you could attack or damage the blockchain creation tools on a private corporate server, you could effectively control 100% of their network and alter transactions however you wished. This has a set of particularly profound adverse implications during a financial crisis or debt crisis like the financial crisis of 2007-08, where politically powerful actors may make decisions that favor some groups at the expense of others, and the Bitcoin blockchain is protected by the massive group mining effort. It's unlikely that any private blockchain will try to protect records using gigawatts of computing power. It's time-consuming and expensive. He also said, within a private blockchain there is also no race, there's no incentive to use more power or discover blocks faster than competitors. This means that many in-house blockchain solutions will be nothing more than cumbersome databases. Blockchain analysis. The analysis of public blockchains has become increasingly important with the popularity of Bitcoin, Ethereum, Litecoin and other cryptocurrencies. A blockchain, if it is public, provides anyone who wants access to observe and analyze the chain data, given one has the know-how. The process of understanding and accessing the flow of crypto has been an issue for many cryptocurrencies, crypto exchanges and banks. The reason for this is accusations of blockchain-enabled cryptocurrencies enabling illicit dark market trade of drugs, weapons, money laundering etc. A common belief has been that cryptocurrency is private and untraceable, thus leading many actors to use it for legal purposes. This is changing, and now specialized tech companies provide blockchain tracking services, making crypto exchanges, law enforcement and banks more aware of what is happening with crypto funds and fiat crypto exchanges. The development, some argue, has led criminals to prioritize use of new cryptos such as Monero. The question is about public accessibility of blockchain data and the personal privacy of the very same data. It is a key debate in cryptocurrency and ultimately in blockchain. Uses. Blockchain technology can be integrated into multiple areas. The primary use of blockchains today is as a distributed ledger for cryptocurrencies, most notably Bitcoin. There are a few operational products maturing from proof of concept by late 2016. Businesses have been thus far reluctant to place blockchain at the core of the business structure. Cryptocurrencies. Most cryptocurrencies use blockchain technology to record transactions. For example, the Bitcoin network and Ethereum network are both based on blockchain. On May 8, 2018, Facebook confirmed that it would open a new blockchain group which would be headed by David Marcus, who previously was in charge of Messenger. Facebook's planned cryptocurrency platform, Libra, was formally announced on June 18, 2019. Smart contracts. Blockchain-based smart contracts or proposed contracts that can be partially or fully executed are enforced without human interaction. One of the main objectives of a smart contract is automated escrow. An IMF staff discussion reported that smart contracts based on blockchain technology might reduce moral hazards and optimize the use of contracts in general. But no viable smart contract systems have yet emerged. Due to the lack of widespread use, their legal status is unclear. Financial services. Major portions of the financial industry are implementing distributed ledgers for use in banking, and according to a September 2016 IBM study, this is occurring faster than expected. Banks are interested in this technology because it has potential to speed up back-office settlement systems. Banks such as UBS are opening new research labs dedicated to blockchain technology in order to explore how blockchain can be used in financial services to increase efficiency and reduce costs. Berenberg, a German bank, believes that blockchain is an overhyped technology that has had a large number of proofs of concept, but still has major challenges, and very few success stories. The blockchain has also given rise to initial coin offerings, ICOs, as well as a new category of digital asset called security token offerings, STOs, also sometimes referred to as digital security offerings, DSOs. STO/D.S.O. may be conducted privately or on a public, regulated stock exchange and are used to tokenize traditional assets such as company shares as well as more innovative ones like intellectual property, real estate, art, or individual products. A number of companies are active in this space providing services for compliant tokenization, private STOs, and public STOs. Video games. A blockchain game, CryptoKitties, launched in November 2017. The game made headlines in December 2017 when a CryptoKitty character, an in-game virtual pet, was sold for more than $100,000. CryptoKitties illustrated scalability problems for games on Ethereum when it created significant congestion on the Ethereum network, with about 30% of all Ethereum transactions being for the game. CryptoKitties also demonstrated how blockchains can be used to catalog game assets, digital assets. Supply chain. There are a number of efforts and industry organizations working to employ blockchains in supply chain logistics and supply chain management. The Blockchain in Transport Alliance, BITA, works to develop open standards for supply chains. Everledger is one of the inaugural clients of IBM's blockchain-based tracking service. Walmart and IBM are running a trial to use a blockchain-backed system for supply chain monitoring. All nodes of the blockchain are administered by Walmart and are located on the IBM cloud. Hyperledger Grid develops open components for blockchain supply chain solutions. Other uses. Blockchain technology can be used to create a permanent, public, transparent ledger system for compiling data on sales, tracking digital use and payments to content creators, such as wireless users or musicians. In 2017, IBM partnered with ASCAP and PRS for Music to adopt blockchain technology in music distribution. Imogen Heap's Mykelia service has also been proposed as blockchain-based alternative that gives artists more control over how their songs and associated data circulate among fans and other musicians. New distribution methods are available for the insurance industry, such as peer-to-peer insurance, parametric insurance and microinsurance following the adoption of blockchain. The sharing economy and IT are also set to benefit from blockchains because they involve many collaborating peers. Online voting is another application of the blockchain. The use of blockchain in libraries is being studied with a grant from the U.S. Institute of Museum and Library Services. Other designs include: Hyperledger is a cross-industry collaborative effort from the Linux Foundation to support blockchain-based distributed ledgers, with projects under this initiative including Hyperledger Burrow, by Monax, and Hyperledger Fabric, spearheaded by IBM. Quorum, a permissionable private blockchain by JP Morgan Chase with private storage, used for contract applications. Tezos, decentralized voting. Proof of existence is an online service that verifies the existence of computer files as of a specific time. Types. Currently, there are at least 4 types of blockchain networks: public blockchains, private blockchains, consortium blockchains and hybrid blockchains. Public blockchains. A public blockchain has absolutely no access restrictions. Anyone with an internet connection can send transactions to it as well as become a validator, that is, participate in the execution of a consensus protocol. Usually, such networks offer economic incentives for those who secure them and utilize some type of a proof of stake or proof of work algorithm. Some of the largest, most known public blockchains are the Bitcoin blockchain and the Ethereum blockchain. Private blockchains. A private blockchain is permissioned. One cannot join it unless invited by the network administrators. Participant and validator access is restricted. Hybrid blockchains. A hybrid blockchain has a combination of centralized and decentralized features. The exact workings of the chain can vary based on which portions of centralization/decentralization are used. Academic research. In October 2014, the MIT Bitcoin Club, with funding from MIT alumni, provided undergraduate students at the Massachusetts Institute of Technology access to $100 of Bitcoin. The adoption rates, as studied by Catalini and Tucker, 2016, revealed that when people who typically adopt technologies early are given delayed access, they tend to reject the technology. Blockchain and internal audit. The need for internal audit to provide effective oversight of organizational efficiency will require a change in the way that information is accessed in new formats. Blockchain adoption requires a framework to identify the risk of exposure associated with transactions using blockchain. The Institute of Internal Auditors has identified the need for internal auditors to address this transformational technology. New methods are required to develop audit plans that identify threats and risks. The Internal Audit Foundation study, Blockchain and Internal Audit, assesses these factors. The AICPA has outlined new roles for auditors as a result of blockchain. Energy use of proof of work blockchains. The Bank for International Settlements has criticized the public proof of work blockchains for high energy consumption. Nicholas Weaver, of the International Computer Science Institute at the University of California, Berkeley, examines blockchains' online security, and the energy efficiency of proof of work public blockchains, and in both cases finds it grossly inadequate. The 31.45 TWh of electricity used for Bitcoin in 2018 produced 17.22.9 Go2. Journals. In September 2015, the first peer-reviewed academic journal dedicated to cryptocurrency and blockchain technology research, Ledger, was announced. The inaugural issue was published in December 2016. The journal covers aspects of mathematics, computer science, engineering, law, economics and philosophy that relate to cryptocurrencies such as Bitcoin. The journal encourages authors to digitally sign a file hash of submitted papers, which are then timestamped into the Bitcoin blockchain. Authors are also asked to include a personal Bitcoin address in the first page of their papers for non-repudiation purposes.